Welcome, this is Ms. Gergen, and we are about to start question number 10 on the 2014 released SOL test for the state of Virginia. The question says, which polynomial is equivalent to the quantity 18n squared minus 9n plus 1 divided by the quantity 3n minus 1? Assume the divisor is not equal to 0. In this problem, they're asking us to use operations of polynomials to simplify a division. So I like to write these in fraction form. 18n squared minus 9n plus 1 divided by 3n minus 1. Now, a quadratic function can always be broken down into two linear factors that when multiplied will give you a quadratic product. So what we're looking for are the factors of 18n squared minus 9n plus 1. So when I factor this problem, the first thing I always want to check for is a greatest common factor. If I look at the coefficients 18, 9, and 1, is there a number that multiplies into each of these coefficients? And 1 is the only number that will go into all of these. Therefore, we do not have a GCF that we can factor out of the problem. So at this point, I've taught my students a box method of factoring that really helps them understand grouping a little bit better. So in the box method, because we have a trinomial and we're going to end up splitting the middle term, I'm going to create 4 boxes. And I'm going to put the first box in the first term in the first box. And I'm going to put the last term in the last box. Now everything else works just like grouping. I'm going to multiply A and C together, and 18 and 1 is going to be 18. So I'm looking for factors of 18, and there are many factors of 18, but I'm specifically looking for ones that add up to be negative 9. So because I'm looking for two numbers to add to be negative and multiply to be positive, that tells me that both of my factors have to be negative. That's the only way I'm going to multiply to be a positive number and add to be a negative number. So I'm going to start off with negative 1 and negative 18. I can always start with 1 in the number when I'm doing my factors. Next thing, I'm going to try negative 2 and negative 9. And then finally, I've got negative 3 and negative 6. Because those two factors are so close together, that means I'm probably done listing my factors. All right, of those, the only ones that add up to be negative 9 are negative 3 plus negative 6. So these are the factors that work for what I am looking for. So I'm going to write those in the box, and the really nice thing is, it doesn't matter what box you write them in. Just like grouping, you can put it either way. So I have a negative 3 in and a negative 6 in. Okay? Now I'm going to take the GCF out of every column and every row. So of the first column, 18n squared and negative 3n, I can take out a 3 and I can take out an n. Of the second column, negative 6n and 1. The only thing I can take out of either of those is a 1. But be careful, I just made a small error here. The number in this box in the corner is negative, so I want to make sure that what I take out is negative. So I have 3n minus 1. Okay, go into the first row, 18n squared and negative 6n. The greatest common factor of that is going to be a 6 and an n. If you ever need to check yourself, multiply your lengths and your widths. 6n times 3n does give you the area 18n squared. Okay, my last row, I have negative 3n and positive 1. Again, because this outside box is negative, whatever factor I'm going to take out is going to be negative. Now, the only number that goes into 3 and 1 is going to be 1. So what I've done is I have factored my polynomial. So let me just slide this over here. And we're just going to rewrite it in factored form. So I had a length of 3n minus 1 and a width of 6n minus 1. That's still being divided by 3n minus 1. Now what we do know about multiplicative inverses is that if I am using a division like this and I have the same thing on the top and the bottom, they cancel out to be 1. So the answer that I'm looking for is 6n minus 1, because that is what remains after we cancel out the top and the bottom that are the same. Okay? If you're looking for a shortcut to this, I always tell my kids to look at the first coefficients and the last coefficients. If you do 18 divided by 3, I'm going to get a 6. So I can definitely cross that out. And if I look at n squared divided by n, I'm going to have an n. So I can get rid of that term with an n squared on it. And then finally, when I do 1 divided by negative 1, I'm going to get negative 1, which allows me to cross out this term. All right, thank you so much for listening.